Okay, so now we're in section 3.4, which deals with slopes and rates of change. Okay, so let's look at this first graph here. What do we notice about this? So we talked, okay, anyway, what do we notice about the slope of this graph here? What do we notice about the slope of the first graph? What kind of graph is it? Okay, so for this one, we want to find out what the slope of this line is and then interpret the meaning of the slope. So what's happening? So as we've noted that the first one is a positive slope. Okay, it is increasing. All right. So if we wanted to figure out the rate of its increase, we can just look at the graph here. Right. So what you want to do is you want to create a triangle, okay, where each of your vertices of your triangle are at the snapshot of the grid. Okay, so you wouldn't want something like this, right? Because that's going to be a little bit harder because uh, to pinpoint that. But if you find ones that are exactly on the grid, then those are going to be a lot easier. Okay, so in this case, we want to see what's happening. Well, as you can see, right, this is going up one and then over two. Okay, so the same thing, this is going up one over two. So it's rising one, okay, and running two, rise over one, okay? So the slope of here will be what? 1/2, right? So the slope for this column is going to be 1/2 because it rises, run one, and then runs two, okay? And this is a positive slope and it's increasing, right? Okay, so you guys try the next one there. What's the slope? And then describe it. Okay, so in this case, the first graph we said is positive, okay, and it was increasing. So we did rise over rise one and over two. This one is a negative slope on the bottom one, okay. We still use rise over run up two over 3, but again, we know that this blue line here is negative, so we put a negative there. Or we could have went down to over 3, down to over 3, so that's the slope, right? So it's a negative slope, and then this is decreasing. Okay. So for the next one, we want to find the slope of the line passing through the 2 points. So we want to find the slope of the line passing through the 2 points. Okay, so let's try one here. So we have, say, negative, um, something. So we have, say, 1, 2, and then 2, 4, right? So to find the slope of this line, or passing through these 2 points, right, we need to use the slope formula. Okay, does anybody remember the slope formula? Well, it's just y2 minus y1, x2 minus x1. Okay, so in this case, you would label this x1, y1, x2, y2, and we just plug it in. So y2, that means that's the second coordinate, right? So these little numbers in the bottom are called subscripts. Okay, this is a subscript. Okay, that's a subscript. The numbers in the bottom here. All right. So our y2 is 4, so it's referring to the second y value, minus y1 is 2, and then x2 is 2 minus 1, right? So that's going to give us 4 minus 2 is 2, 2 minus 1 is 1. So our slope here, which is m, right? That's going to give us 2, okay? All right, so why don't you guys try one? So, um, say we have negative 1, 6, and negative 1, negative 4. Okay. Actually, that's good enough. Let's just try that one there. This, so again, we're going to do exactly the same thing as we did before. We're going to label this x1, y1, x2, y2. Now, technically, you can label, it doesn't matter which one you identify as x1, y1. It could be the left one, or you can be the right one. Okay, and make this the first point x2, y2. It doesn't matter, right? If they have the same slope, then it doesn't matter, you know, which one goes first. Okay, because the output will be the same. Okay, so again, we have this is our slope, y2 minus y1 over x2 minus x1. So that's going to give us negative 4 minus 6 and negative 1 minus negative 1. So negative 4 minus 6 is a negative 10. And then these two negatives here are going to become positive. So negative 1 plus 1 will give us 0. So negative 1, negative 1 plus 1. Okay. Negative 1 plus 1 it's going to give us 0 in the denominator, right? So can we divide by 0? No, we can't divide by 0. So we can't divide by 0. Okay? So what's the answer here? Can't divide by 0. What's the answer? Undefined, exactly. Right? So this would be undefined. Okay, now if it was, say, 0 divided by -10, then that would be 0, right? 0 divided by any number except 0 would be 0. Okay? So just remember that. All right, so let's look at a word problem here. And we're not going to do every part of this, we're just um, getting an idea what a word problem will look like. Okay, it says here analyzing tetanus cases, list numbers of report cases of tetanus in the United States for selected years. Okay, here we have a table, okay, for the cases, and then make a line graph of the data, find the slope of each line segment. We're just going to find one, all right, and then interpret each slope at the rate of change. Okay, so as I mentioned, this is a table for the tetanus cases. And then it wants us to make a line graph. So to save us on time, I already have that here. All right, so there is our line graph based off of this information. Okay, so basically, it's like a scatter plot. Okay, so this would be your, this would be your X coordinate and this would be your Y coordinate. Okay, so it would be like 1960 and 368. Okay. All right. So let's look at the second part here. Can we find the slope of, again, we don't have to do all of them right here. I just want to find the one of them. Okay, we want to find one of them. So let's say we wanted M1. So find the slope line segment of M1. Okay. Normally I like to, if it was a straight line, then I would just pick the ones that are exactly on the grid line. However, none of these ones except for 3, okay, um, lie on the grid line, the X and Y part. So, um, so let's make our life a little bit easier and pick M3 instead of M1. So let's find the slope of M3. Okay, and then to be on the same page here, let's say that this was 90. So this here is 90. Okay. All right, so go ahead and figure that out. So again, we need to find this. What's the slope of this 2 points here? Okay, and then this part here, this X value, the Y is 90. See if you can figure that out. What would be the slope? What would be the slope of M3? This is supposed to say slope. Okay, so remember, in order to make a line, we need 2 points. And in order to find the slope of the line, we need 2 points. So for this one, right, this one, again, we like to pick the one exactly on the grid line because we know what that number is. So in this case, that would be 1960. Okay, so 1960. And then on the Y value, I'm sorry, not 1960. Yeah, that's right. Oh my goodness gracious. 1980. Go back here. 1980 and 100. And then we have 1990. So this one right here. It's 1990 and 90. Yeah, 1980. Yeah. Okay. All right. So we're just going to use the slope formula, right? So we're going to have y2 minus y1, x2 minus x1. Okay. So then we can pick, right? So we can make the first point x1, y1, or we can make the second point x1, y1. Okay, so again, it doesn't matter. So this would be x1, y1. I'll just make that my first point, and then this would be x2, y2. Okay. All right, so y2 is going to be 90, y1 is 100, and then we have x2, which is 1990, and then we have x1, which is 1980. Okay, so 90 minus 100 will give us negative 10, and 1990 minus 1980 is going to give us 10. All right, so negative 10 divided by 10 is going to give us a negative 1. Okay, so the slope of this line segment is negative 1. All right, so part C now is asking us interpret each slope as a rate of change, right? So basically the rate is going to change for each of the slope, right? Because this one here, slope number 1 is going to be steeper. So the rate of this is going to be much more drastic versus slope number 5 or slope number 4. Okay. So for each one of those, the slope is going to vary. For in this case, part C, all right, for us, the we said Y, right? Y is talking about the cases, so this is going to be the cases over the years, right? So in this case, the rate is going by what? The negative 10 is the negative indicates that it's decreasing. So the cases is going down 10 cases per 10 years, or in this case, one per year. Okay, as we reduce that fraction. Okay, so but the bottom line here is that if we were to find the slope for each one of these line segments, they're going to be different because it's going to vary. Okay. Now, if this was a, one if all of these were all lined up, okay, so like if I had the same dot over here, another one over here, okay, there's one here, here, okay, something like that. Then, and it was a straight line coming down, okay, then since it's a straight line, it doesn't matter which point I pick, technically, I would get the same rate, okay, because it's on the same line. So what I'm saying is if this was, um, if this was, just a straight line coming here, it doesn't matter what I pick, but it makes it, since some of these points are not exactly on the grid line, okay, so like this one's like over here, like this one here, right? This point here will be easier to pick, all right? Or even this point here is also easier to pick versus this point here because we know exactly, what those numbers are. So this one would be 1970 and 300, okay? And this one would be, 1980 and 200. Yeah. Okay. So, um, So these ones would be the best ones to pick. These ones here versus the other ones because they're not exactly on the grid line. But anyway, we don't have that, but I'm saying it would, if we did, if they give us a different graph and it looked like that, then those are the points you would want to pick. Okay. So our units for this one would be -1 case per year, right? It's decreasing by 1 case per year.